This Google-style namey excited quiz Google-style focuses on understanding and fixing oversmoothing in Gaussian process regression models using scikit-learn. Well, explore how the model's hyperparameters and kernel impact smoothness.
The core issue: the model is too smooth, missing important details in the data. It's like trying to draw a complex landscape with only blurry strokes. Break time 300 milliseconds. We need to make it more detailed. This is the core question. I'll guide you through each option to find the ones that improve the model's ability to capture fine details in data. Increasing alpha. Google style name sorrowful worsens Google style. The problem: alpha controls the assumed noise level. Higher alpha means more assumed noise in a smoother model. Think of it like adding more blur. Decreasing alpha is a good solution. A lower alpha assumes less noise, allowing the model to fit the data more closely. Less blur, more detail. Switching to a different kernel, like rational quadratic, gives a great solution. The kernel function dictates the model's flexibility. RBF kernels are smooth. Rational quadratic kernels are more flexible, allowing for better fitting of complex data. Increasing the data points is also a good approach. More data gives the model more information to learn from. Think of it as having more reference points to create a more accurate drawing. This is the title of the problem we're tackling. We're using a say as interpret as characters Gaussian process regressor. Say as interpret as spell out GPRSAY as a powerful machine learning model. But its predictions are too smooth. They miss the finer details in the data. Break time 300 ms. I am focusing on how to fix this oversmoothing issue. The problem is that the say as interpret as characters GPR say as model is producing predictions that are too smooth. Break time 300 milliseconds. They don't capture the intricate variations and nuances present in the actual data. Break time 300 ms. Think of it like drawing a graph. A too smooth line would miss the peaks and valleys of the actual data points. Here's the core question: what adjustments can I make to the say as interpret as characters GPR say as settings to reduce this excessive smoothing? Well, explore different options to improve the model's ability to capture the data's complexities. This option suggests increasing the alpha value. Alpha controls the assumed noise level in the data. Break time 300 milliseconds. Increasing alpha tells the model, hey, there's a lot of noise, smooth things out a lot. Break time 300 milliseconds. This would make the problem worse, not better. So it's incorrect. This proposes lowering the alpha value. By decreasing alpha, I am telling the model, assume less noise, pay more attention to the data's details. Break time 300 milliseconds. This is a good approach because it can reduce oversmoothing. This would work, making it a correct answer. This involves changing the kernel function. The kernel determines how the model measures similarity between data points, impacting smoothness. Break time 300 ms. The say as interpret as characters RBF say as kernel is very smooth. The say as interpret as characters rational quadratic say as kernel is more flexible. Break time 300 ms. Switching to a more flexible kernel could fix the oversmoothing problem. It's a correct option. Increasing the data points provides more information for the model to learn from. Break time 300 milliseconds with more data. The say as interpret as characters GPR say as can better capture the true shape of the underlying data, potentially reducing oversmoothing. Break time 300 ms. This option is also a good fix. It's a correct answer. This is the title of the problem we'll be tackling. We are using a Gaussian process regressor GPR, a machine learning model, and its predictions are too smooth, they miss the finer details of the data. I am facing a common issue with GPR, the predictions are overly smooth, lacking the detail in the original data. This means the model is too simplified and does not capture the complexity accurately. I need to figure out how to adjust my GPR model to get more detailed, less smooth predictions. To do so, I have a few modification options to consider. Break time 300 ms. I will need to analyze these options to find the most effective changes. The alpha hyperparameter controls the level of assumed noise in the data. Break time 300 ms. If I decrease alpha, I tell the model there's less noise, allowing it to fit the data more closely and thus reduce oversmoothing. Google style name excited, that might be a good option. Google style. The kernel function determines how smooth the model is. The radial basis function RBF kernel is known for its smoothness. Break time 300 ms. Switching to a rational quadratic kernel, which is more flexible, can help me capture more detailed patterns in data, reducing the oversmoothing effect. Google style name friendly. This sounds promising. Google style. More data usually leads to a better model. Break time 300 ms. With more data points, my model will better capture the nuances and reduce oversmoothing, particularly if the current dataset is too small to accurately represent the underlying function. Google style name enthusiastic. Let's try this. Google style. I see the problem is that your Gaussian process regressor model is producing predictions that are too smooth, it's missing the fine details in the data. Break time 300 milliseconds. Think of it like trying to draw a mountain range with only smooth curves. You'd lose the jagged peaks and valleys. Break time 300 milliseconds. We need to make the model more flexible. The alpha parameter controls how much noise I assume is in the data. Break time 300 ms. A higher alpha means I believe there's a lot of noise, which makes my model smoother to avoid fitting the noise itself. Break time 300 milliseconds. So, decreasing alpha tells the model that I expect less noise, allowing it to fit the data's wiggles more closely and reduce the oversmoothing. The kernel function determines how smooth the model is. Break time 300 milliseconds. Think of it as the brush I am using to paint the function. Break time 300 ms. The radial basis function RBF kernel is very smooth. Break time 300 milliseconds. Switching to a rational quadratic kernel gives me a different brush, one better at capturing more complex shapes. Break time 300 ms. It will likely lead to a less smooth, more detailed prediction. More data means I have a better understanding of the underlying pattern. Break time 300 milliseconds. Similar to having more points to connect when drawing a curve. Break time 300 ms. With more data, the model can capture more details and reduce oversmoothing. But it's not a guaranteed fix if the model is fundamentally too smooth. I am addressing the problem of oversmoothing in Gaussian process regression, a machine learning technique used to model datasets. Break time 300 milliseconds. Oversmoothing means the model is too smooth and misses important details in data. Break time 300 milliseconds. We are going to find ways to make the model more flexible. I would decrease the alpha hyperparameter. Break time 300 milliseconds. Alpha controls the assumed noise level in your data. A lower alpha means I am assuming less noise, making the model less cautious and allowing it to fit the data more closely, thus potentially reducing oversmoothing. I would try a different kernel function. Break time 300 milliseconds. The kernel determines how smooth the model is. The radial basis function RBF kernel is known for its smoothness. A rational quadratic kernel offers more flexibility, capturing complex patterns and potentially addressing the oversmoothing issue. Break time 300 milliseconds. I would increase the amount of data. More data points give the model a more complete picture of the underlying function, making it less prone to oversmoothing and allowing it to learn the nuances of the data better. Break time 300 milliseconds. Think of it like this: the more examples I show you, the better you'll understand the pattern. This question asks you to identify ways to fix a problem where your model is too smooth it doesn't capture the details in your data well enough. We need to find changes that make the model fit the data more closely. Break time 300 milliseconds. Think of it like trying to draw a detailed map with a really thick crayon. You can't get the fine details. The alpha hyperparameter controls how much noise we assume is in the data. A lower alpha tells the model, hey, I think the data is pretty clean, let's fit it very closely. This helps reduce oversmoothing. Break time 200 milliseconds. It's like using a thinner crayon to draw your map. The kernel is like the type of brush we use for painting. An RBF kernel tends to make smooth predictions. Using a rational quadratic kernel lets the model adapt better to complex patterns, reducing oversmoothing. It gives us more flexibility to capture detail. Break time 300 milliseconds. Think of switching from a smooth brush to one that can do both fine lines and broad strokes. More data gives the model a better idea of what the underlying function actually looks like. More data points can improve a model's ability to capture the details of the dataset, reducing the oversmoothing. Break time 300 milliseconds. It's like having more information to work with, leading to a more accurate and detailed map. Increasing alpha makes the model assume there's more noise in the data, causing it to smooth out the results even more, making the oversmoothing worse. Break time 200 milliseconds. This is like using an even thicker crayon. You lose even more detail.